A quiet flaw hid in plain sight, not in a lab, not in a field, but in the rules meant to protect the meals millions of people ate every day. For years, the expected cooking temperature for ground beef lagged behind what science already understood about E. coli's survival. That gap stayed unchallenged, unnoticed, unquestioned, until children began arriving at hospitals with symptoms no routine stomach illness could explain. In early 1993, emergency rooms across several states started seeing the same pattern: severe abdominal pain, rapid dehydration, a dangerous form of kidney failure that physicians rarely observed in healthy kids. The cases looked isolated at first, until the reports converged. Each child had eaten the same meal from the same fast food chain. As investigators traced the path back to the source, the first hidden mechanism emerged. The bacteria behind the crisis wasn't just E. coli. It was a highly virulent strain capable of causing life-threatening complications at exceptionally low doses. Yet the existing safety standards didn't account for it. The system had prepared for yesterday's threats, not the ones evolving in real time. The meat used in the chain's burgers came from multiple suppliers, each following regulations that focused more on visual inspection than microbial risk. Contamination could slip through without triggering alarms. The final safeguard, the cooking process, relied on a temperature that scientific literature had already shown to be insufficient against the most dangerous strains. It wasn't negligence. It was a framework built for a different era. In processing plants, inspectors checked surface cleanliness and physical defects, but the deadly pathogen existed deep inside the ground beef, protected within the mixture. No visual test could detect it, and routine microbial testing was not yet standard practice for every batch. This was the second hidden mechanism, a structural blind spot in how contamination risk was assessed. When the outbreak peaked, the scale forced a reckoning. Hospitals filled with young patients facing complications that even seasoned doctors feared. Families demanded answers, regulators faced mounting pressure, and the food industry realized that a long-standing assumption that visual inspection could protect the public had collapsed. The crisis pushed scientists and policymakers to re-examine every step of the meat safety chain. What they found reshaped national standards. Microbial testing became mandatory in contexts where it had been optional. Ground beef safety thresholds were rewritten with modern science in mind. And cooking guidelines were updated to reach temperatures that eliminated high-risk strains more reliably. Each change reflected an uncomfortable truth. A system built on outdated criteria had been caught off guard by a pathogen that didn't follow old rules. The outbreak also shifted how responsibility was defined. Fast food chains, suppliers, and regulators shared a new understanding. Safety wasn't a final step action. It had to be engineered from the beginning, starting with farm practices, moving through processing controls, and reinforced by lab verification. A complete chain of custody, not a single checkpoint. For the first time, large companies began integrating scientific advisors into routine operations. Temperature monitoring became non-negotiable. Cooking standards aligned with microbial realities, and regulators acknowledged that pathogens evolve faster than policies. To keep the public safe, the system itself had to evolve. The reforms that followed transformed how meat is handled, tested, and regulated, not just in fast food chains, but across processing plants, inspection agencies, and national policy frameworks. A new era of food safety emerged, one built around microbial science, real-time risk assessment, and a recognition that invisible threats demand visible accountability. Decades later, the outbreak still serves as a case study for every new generation of food safety professionals, not because of the tragedy alone, but because of what it revealed, that every system, no matter how established, can fall behind the challenges it faces. And without constant improvement, old rules can become new risks. So the question now is simple. If a pathogen once exploited a single weakness in the chain, could another one find the next? The lessons remain. Vigilance is not a reaction. It's the foundation of food safety, and its strength depends on how well we learn from the failures that forced the system to change.